Let's go fly a kite up to...
Everyone loves kite flying, but which kite designs actually fly the most successfully? More specifically, do certain tail designs affect a kite's flight? When exploring this question, we decided to build a basic sled kite with interchangeable tails. Sled kites are known for being durable, reliable, and versatile, as well as simple in design, construction, and flight. So this sled kite design would allow the focus of the experiment to be on the comparison of the tails. We decided to test the effects of long versus short and double versus single tails on flight. The short tails would be 6 feet long, while the long tails would be 12 feet long. When building our sled kite, we decided to use materials that were lightweight, cheap, easily attainable, replaceable, and safe. For these reasons, we decided to build our kite out of garbage bags, tape, 1/4-inch dowels, and yarn. These materials were all easy to work with and had no chance of harming anyone involved. Using the tape measure and specified dimensions, we first cut the basic shape of the kite out of 2 layers of garbage bags and taped the layers together. Then we cut 2 slits in each side of the kite, inserted the dowels, and taped them in place. We taped a sea paw on the kite for decoration and attached the yarn to either side of the kite. Our testing plan had 2 phases. The first phase involved flying the kite behind a car moving at around 15 miles per hour. This allowed the tails to be compared with a consistent wind speed and nearly identical environmental conditions. Smoothness of flight, ease of launch, and overall stability were rated on a scale of 1 to 5 for each tail type, with 5 being the best and 1 being the worst. The tail design with the highest score is the best option. The second phase involved flying the kite in the traditional manner, this time evaluating the kite's smoothness of flight, overall stability, ease of directing, ease of launch, and ability to withstand changing environmental conditions for each of the tail designs. This testing method would allow us to gauge the handling qualities more directly. Some of the initial problems we encountered during our testing included finding a day with adequate wind, the tails getting twisted in the wind, technical difficulties, and finding a large, safe, and vacant location for the car phase of testing. After finding a windy day, getting kicked out of Kings Island and settling on an elementary school parking lot, untangling our tails, and learning how to use our cameras, we began by testing the kite without any tails attached. In this condition, although the kite was easy to launch, it was unstable in flight, difficult to control, and spun around a lot. Flight patterns were unpredictable and, at times, erratic. Here are the scores for the kite without a tail, which received an overall score of 19. Next, we flew the kite with a single short tail. In this form, the kite was slightly more stable and controllable. The kite remained far steadier than it had without any tail, particularly when going around a turn or encountering a change in wind speed when flying in the traditional way. Here are the scores for the single short tail, which received an overall score of 23. Then we flew the kite with a double short tail. It was clear that the double tail made the kite much more balanced, allowing the kite to fly in more consistent patterns and straighter lines. The kite was also much easier to control. Here are the scores for the double short tail, which received an overall score of 30. We then flew the kite with a single long tail. This tail design made the kite noticeably more stable than with the single short, though not as balanced as the double short. However, the kite was still reasonably easy to control and remained relatively stable in flight most of the time. Here are the scores for the single long tail, which received an overall score of 26. Finally, we tested the kite with a double long tail. This tail design made the kite somewhat difficult to launch because the tails were long enough to get caught on things or stepped on. However, once in flight, this particular tail design made for by far the most stable flight. The kite was also easiest to control and effortless to keep in the air while in this state. Here are the scores for the double long tail, which received an overall score of 34. The overall results of the testing indicated that increased stability positively correlates with longer tails, and that double tails increase balance and controllability. Also, the total length of the tails added together matters less than the placement and distribution of the tails. This means that a kite with a double short tail flies more successfully than a kite with a single long tail, despite the fact that the total amount of tail is actually the same in both cases. Utilizing both the car and traditional kite flying methods to test the tails allowed us to form the conclusion that changing environmental conditions affect handling qualities more significantly than other factors. This was supported by the fact that the kite flew relatively well with each of the different tail designs when using the car, though this was not the case when the kite was flown in the more traditional manner. Based upon the evaluations of smoothness of flight, ease of launch, overall stability, ease of directing, and ability to withstand changing environmental conditions for each of the different tail designs, we concluded that the double long tail is the optimal tail design of the ones we tested for a sled kite. This was evident through both car and traditional testing, for which the double long tail design received the highest overall score of 34.